Okay, welcome to part 4 of our review for the final exam for Calc 2. Let's continue. Number 7, it says to find the radius of convergence and interval of convergence for this series. So what we will do is use the ratio test. Okay, so ratio test will just be our limit as n goes to infinity, an absolute value of the n plus 1 term of our series over our an, our original series. Okay, and then the result of this limit for convergence would be as long as we have it less than 1. Okay, and we'll get to that as we go through this. Alright, so let's set this up. So we'll start off with the limit as n goes to infinity. The n plus 1 term means we just add 1 to all the n's in the original series. So we'll have absolute value of 2 to the n plus 1 times x minus 1 to the n plus 3 all over n plus 1. And instead of dividing by an and having a complex fraction, I will multiply by the reciprocal of an to keep it a little bit more streamlined. So we'll have x minus 1 to the n plus 2. Okay, so what we'll do next is we'll start to pull out some of these terms just to allow us to cancel. For example, 2 to the n plus 1 I could say is 2 times 2 to the n. X minus 1 to the n plus 3 I will say is x minus 1 times x minus 1 to the n plus 2. So you just wanted to get some of those to match with the original an terms. And then we have 2 to the n over x minus 1 to the n plus 2. So now you could cancel, as I mentioned earlier. You have a 2 to the n you could cancel with a 2 to the n. X minus 1 to the n plus 2 would cancel with x minus 1 to the n plus 2. Okay, so now let's look at what we have left. So we have limit and then we have our 2 on top with an n. I'm going to write the n terms I'll write separately. N plus 1 in the denominator. And what I'll do is I'll treat the x minus 1, that'll be what's left inside. Okay, what I like to do is keep all the n terms, they're kind of like coefficients. I can pull them outside. They're the ones that are going to be controlled by the n approaching infinity. And I'm not losing my absolute value, but I'm keeping it with the x minus 1 there. Now, this helps me do my limit a little bit easier. So, again, I will divide everything in this portion by the highest degree term in the denominator, which is the n. Divide everything by n. So that will leave me with, well, I have, this will become 0, right, as n goes to infinity. These would cancel, leave me with 2, this will be 1. So I have 2 over 1, which is just 2. Okay, so 2. So this will turn to 2. I still have my absolute absolute value x minus 1. Okay, and I know that this will be set up for convergence, so that now I can say, as a result of my ratio test, this has to be less than 1. Right? And that, as we all remember from ratio test, right, if that limit turns out to be less than 1, that series would be a convergent series. Okay, so that's where this comes in. We have to say that it's got to be less than 1. Okay, now isolate your absolute value portion. Okay, so we will remove this 2. It's being multiplied, so we will divide both sides by 2. So that gives me my absolute value of x minus 1 is less than 1/2. Okay, so what that means is our radius will equal 1/2. Okay, now let's do a little additional work. We have x minus 1. We'll go back up here. X minus 1 is an absolute value. It's less than 1/2. So what does that mean in terms of algebra? Remember, that means is it's less than 1/2, and I'm removing the absolute value bars, but at the same time it's greater than -1/2. Okay, and if we solve this using what we know about compound inequalities, we'll add 1 across the board on all 3 sides. We have the left side, the middle, and the right, just to get the x by itself. So we'll have x less than 1/2 plus 1 is 3/2. And -1/2 plus 1 will be positive 1/2. Okay, so now this sets up our potential interval of convergence. Okay, so what we'll do then, I'm going to open up a new page just to give myself more room. What we end up next is we end up testing at our possible endpoints for the interval of convergence. And what we mean by test point is we take these values and plug it back into the original series in place of x, because these are x values. Okay, keep in mind your inequality is have an x in the middle. These are x values. Okay, so let me go to a new page. So for our first test, we'll do test of x equal to 1/2. Okay, so that means our summation will be 2 to the n, and then we plug in the 1/2 in place of the x, minus 1. This will be to the n plus 2. And this is all over n. Okay, so now you're going to do a little simplifying here. So we'll have 2 to the n. 1/2 minus 1 is -1/2. Okay, and now we can go a little bit further. 2 to the n. The -1/2 to the n plus 2, we could say, is if we split it apart, numerator to the n plus 2, and then the denominator 2 will join the n at the bottom. Okay, so we'll just have n and then 2 to the n plus 2. Okay, so now we'll keep going. 2 to the n. The negative 1 to the n plus 2. Okay, so this will be just saying negative 1 to the n times negative 1 squared. Your denominator will be 2 to the n times 2 squared. Okay, now what we can do is cancel 2 to the n with 2 to the n. We knew that negative 1 squared will just turn into just 1, which won't affect much here. And then we have the 2 squared turns into 4. So we have negative 1 n over 4n. We could also say this is 1/4 summation negative 1 to n over n. Okay, perfect. What does this mean? So if we remember our summation negative 1 to the n over n, this is known as our alternating harmonic series. Okay, and alternating harmonic series. And just remember that this would converge, okay, by the alternating series test. Okay, you might say, what was the alternating series test? Well, we know that we take our un, which will be what this would be without the negative 1 to the n, so this would be like a 1 over n. Right, so this 1 over n is positive. It's decreasing. And its limit goes to 0. Right, so the 1 over n is positive, it's decreasing. Right, or we say eventually decreasing, and then its limit goes to 0. This will be a convergent case by alternating series test. Okay, now, so that's good. Convergent on the 1. Now let's test the other endpoint. So now we're testing x equals 3 over 2. So again, take the original series, go back and replace x with 3 over 2. Okay, so we have 2 to the n, parentheses, 3 over 2 minus 1 to the n plus 2. This is all over n. Now simplify. 3 over 2 minus 1 is just 1 over 2. N plus 2 over n. Same kind of thing we're going to do as the last one. Okay, so we'll have 2 to the n. We'll have 1 to the n plus 2. We'll have n, and then the 2 for the 1/2. That'll come to the denominator. Become 2 to the n plus 2. So we'll have 2 to the n. Separate 1 to the n times 1 squared. And 2 to the n plus 2 would be 2 to the n times 2 squared. Let's cancel. 2 to the n's would cancel. 1 squared is 1, 2 squared is 4. Okay, so what does this become? This becomes same like the other one. This will be a 4 in the denominator. So 1/4 times 1 to the n over n. Right? Now 1 to the n will just be 1 in every case. Right? So we have a 1 over n. So 1/4 summation 1 over n. What does this mean? This is our original harmonic series times 1/4. Right? You could also think of it as our p series, right? Where p equals 1. So harmonic p series where p equals 1. And remember that when p equals 1, this diverges. Right, so that means for our interval of convergence, therefore interval of convergence would be it converged on the 1/2, diverge on the 3/2 side, so that'll get the parenthesis. And then we said our radius of convergence is 1/2. Okay, and if you're not sure, just remember this is your interval of convergence. Think of the number line, right? When you have a number line, let's say we go 0. Let's go by halves since we have a half. We have 1. We have 3/2. We have 2. Alright, so this is telling us that we have a half and we have 3/2. So what you want to do is place yourself right in the middle. Picture like the center of a circle. Right? Picture yourself right in the middle. What is your radius? Right, so you're going a half this way and a half this way. Right, so your radius of convergence is a half. Okay, and then that's it for that one. Alright, so let's take a look at part B. Part B is down here. Number 7. Given the function is the following, where x is between 0 and 1, then the derivative of the function is circle 1. Okay, well, let's do this term by term. Since this is our function, we could do a term by term differentiation, right? So derivative of x is 1 plus power rule, bring down 2, so we'll have 2x and then reduce the power by 1, so don't need to write it, over 2 plus x cubed, bring down the 3, so multiply 3x squared, right, drop the power, same thing, 4x to the third over 4, dot dot dot. Okay, simplify it. So we have 1 plus, cancel, cancel, so x plus, cancel, cancel, x squared plus, cancel, cancel, x cubed. Okay, so this should remind us of a geometric series, right, where the first term is 1. That's its derivative. Right? So and we're taking a sum of this, so we could literally write what the sum formula would be for that geometric series. Right? First term is 1, and every term thereafter we're multiplying by x. So formula 1 is the first term, 1 minus common ratio, which will be x. Okay, so that is our, right, that's the old summation formula for a geometric series, right? The only thing is, instead of our common ratio being r, right, in this case the common ratio is x. Okay, so that would be our solution. Okay, let's take a look at our next one, number 8. Find the area of a polar region that lies inside the cardioid and outside the circle. Okay, so area of polar regions. Okay, one of my favorite things to do. We would take area. Yeah, remember the formula would be we have 1/2 integral of a to b, and then we have r squared. This will be for the outer polar curve minus r squared of the inner polar curve. This will all be based on d theta. Okay. So, looking at our shape, they don't necessarily have to provide the shape either. This was nice of them to actually provide it. Everybody should know how to graph these. Okay. Regardless, we have to first figure out our limits of integration. Right. So in order to do that, we're going to try to find basically these points right here. Right, that'll tell us where to start, where to end. So the easiest way to do that is to set our two curves equal to one another. Right, we want to find their intersection points. So we would do 2 plus 2 sine theta equals circle is 2. Okay, minus the 2 both sides. We have 2 sine theta equals 0. Divide by 2, so sine of theta equals 0. Where does the sine equal 0? When theta equals 0 and when theta equals pi. Okay, this is good, right? And notice how it does line up, right? This is our 0 angle and this is our pi angle. Okay, so let's set it up. Our outer curve will be the cardioid. Our inner curve will be the circle. And we're trying to get all this, kind of like a little crescent. Okay, so we'll have 1/2 integral 0 to pi. Outer curve 2 plus 2 sine theta squared minus the inner, which is this 2, squared d theta. Okay, so 1/2 there to pi. Foil this out, right? You're going to do 2 plus 2 sine theta times 2 plus 2 sine theta. If you have to, write it out side by side, foil it out. Alright, so we'll get 4 plus 4 sine theta. Another 4 sine theta is 8 sine theta plus 2 sine theta times 2 sine theta is 4 sine squared theta. Okay, and then we have minus 4. Okay, so we have the 4 and then we have the minus 4. They will cancel each other out. So we have the 1/2, 0, pi, 8 sine theta plus 4 sine squared theta. Now, instead of rewriting the 4 sine squared theta, I will not be able to integrate that, so I'm going to replace sine squared theta, okay, with a very popular identity, right? Sine squared is equal to 1 minus cosine of 2 theta all over 2. Okay, now the 4 and the 2, they will cross cancel. We'll be left with a 2 there. So we'll have the 1/2 integral 0 to pi 8 sine theta plus. Okay, and then the 2 I could just distribute. So I have 2 minus 2 cosine of 2 theta d theta. Okay, so now at this stage we're basically ready to integrate this. So I'll have 1/2. Now integral of sine is negative cosine. So with the 8 we have just negative 8 cosine theta plus, this will turn to 2 theta, and then the integral of cosine theta would be sine theta, but factoring in the 2 theta, that means this would have originally been minus sine of 2 theta. I just take its derivative. Sine of 2 theta is cosine of 2 theta times 2. Right? Okay, and then we'll evaluate with pi and 0. Okay, let's plug in the pi, plug in the 0. So negative 8 cosine of pi plus 2 pi minus sine of 2. Okay, and then minus negative 8 cosine of 0 plus 2 times 0 minus sine of 2 times 0. Okay, so now what do we end up with? Cosine of pi, negative 1 plus 2 pi minus sine of 2 pi is 0 minus negative 8 cosine of 0 is 1 plus 0 minus sine of 2 times 0, 0. Sine of 0 is 0. Okay, so let's see what we end up with. We have 1/2. This is negative 8 times negative 1 is 8 plus 2 pi minus, now 0 minus 0, so this is just negative 8 minus negative 8. It's plus 8. So we have 1/2 of 16 plus 2 pi. And if we just distribute the 1/2, we end up with 8 plus pi. And that's our final answer for that one. Okay, let's take a look at our final question for the review. Find the equation for the line tangent to the curve x equals t over 4 plus 2, y equals the square root of t, at the point t equals 4. Okay, so one of the things we have to remember for our equations like this, remember parametrization of equations, we need to get the slope, and then the slope is easily determined by dy dt over dx dt. Okay, that's an important thing. And of course we'll get an x value and a y value by plugging in the t. Okay, it's actually a very basic question, but it can easily be messed up if you don't know or don't remember the basic equation for the slope. Alright, so let's get our dy dt from our y. Right, so if y equals square root of t, which is t to the 1/2, that means dy dt would be 1/2 t and then subtract 1, which means we have 1 over 2 t to the 1/2, or just the square root of t. So that's our dy dt. And then dx dt, very basic, is just 1/4. So it's just 1/4. Okay, so let's get our slope then. Dy dt, 1 over 2 square root t over 1/4. Okay, now what we need is the slope at t equals 4. Right, so we're at t equals 4. So that means we have 1 over 2 square root 4. So 2 times 2, right? Square root of 4 is 2. So we have 1/4 divided by 1/4. A number divided by the same number is equal to 1. So we have a slope of 1. And let's get our x value and our y value. So we have, again, plugging in t equals 4. So x equals 4 over 4 plus 2. That's 1 plus 2 is 3. Y is square root of t, so square root of 4 which is 2. Okay, perfect. So we have a slope of 1. And we have an x and a y. Okay, so slope equals 1. And we have a 0.32. Okay, so we go to our point slope form. Right, so y minus y1 equals mx minus x1. So y minus, this is like x1 and y1. Y minus 2 equals 1, x minus 3. Okay, distributing the 1 just gives us x minus 3. Add the 2 over. So we have y equals x minus 1. And that would be our equation of the tangent line. Okay, so that's it for our final exam review. Hope this will benefit you guys. Good luck on your final exams. Please like and subscribe, and we'll hope to see you soon.